All right, this is take 6 of Dr. Hall recording how to complete task 3, elaborate, for your food burning lab. And I'm going to show you how to do your calculations for this lab in case you get stuck doing the calculations outside of class. So, for example, the marshmallow. Let's suppose that I took the mass of the water and I found it to be 75 grams. My initial temperature of the water was 22 degrees Celsius. The initial mass of the food sample plus the foil was 8.46. When I burned that marshmallow and made it nice and toasty, it wound up being 54 degrees Celsius for the final temperature of water. And then the final mass of the food sample plus the foil was 5.35 grams. So when we calculated the mass of the food sample that actually burned, we're taking the initial minus the final mass. So 3.11 grams. That's how much of the food sample that actually burnt. Then we're going to determine the change in the temperature of water, our delta T. So 54 minus 22. And then we're going to figure out our heat that absorbed by the water. So we use the equation Q equals MC delta T. This is the Q equals MCAT equation. So when I calculate this, my mass of my water that I'm going to use is at 75 grams. And then the specific heat of water is 1 calorie per gram degree Celsius. And this is times 32 degrees Celsius because that was my temperature difference. When I do that calculation, I get 2,400 calories. Then you're going to have to determine the number of kilocalories of food calories released by burning of the sample, remembering that 1 kilocalorie is equal to 1,000 calories. Then you're going to use that to calculate the energy content of the food in kilocalories per gram. Then you're going to use the information off the nutritional label, and the link to the nutritional label is right over here. It'll take you to a document, a Google slide deck that has a picture of what your food is and how many calories there are, and dividing by the calories by the number of per serving by the number of grams in a serving, and then compare your determined energy content to the calculated value from the nutrition label by calculating the percent error. So for your marshmallow, again, your mass was 3.11 grams. The temperature difference was 32 degrees Celsius. The Q equals MCAT was 2,400 calories. And when I convert that number of calories to kilocalories, remember I'm going to divide by 1,000 because there's 1,000 calories in 1 kilocalorie. So I'm going to get 2.4. I'm going to calculate the number of kilocalories per gram of sample because I know the mass of my food burned in grams. So this was 2.4 kilocalories burned per 3.11 grams. So if I do that, I'm going to get 0.77. I divide 0.77 kilocalories per gram of sample. From the slide deck, the marshmallow actually weighs, or the marshmallow is actually 90 calories, and there's 28 grams in a serving. So I divide 90 by 28 grams in a serving so I could get the calories per gram, and I get 3.21 for the marshmallow. And to find the percent error, I could click on this link right here and it'll take me to a percent error calculator. But the percent error, if you may remember from a while back, is the absolute value of the experimental minus the theoretical value divided by the theoretical value times 100. So my experimental value was 0.77. Theoretically, it should have been 3.21. And then I divide it by 3.21, times that by 100, I'm going to get 76%. So that is how you perform these calculations. So it shouldn't take you too long to perform your calculations that you got for your food samples. And if you have any questions, let me know.